Hello everyone, we are Team 4, and our Six Sigma project will focus on the City of Houston Municipal Court Department's System Support Division. Team 4 consists of 5 members. Our team project lead is Sandra Chu, followed by Prachi Jain, Nin Pham, Waram Taneja, and Raman Preet. This slide provides a high-level overview of our quality improvement project methodology. For this project, our team has utilized the Six Sigma philosophy. Through the course of this project, the team has followed the DMAIC framework using a variety of Six Sigma tools to help develop process improvement. The team first initiated the design phase by understanding the voice of the customer, which in turn aided in constructing the SIPOC diagram in order to describe and define the current process. Once this was accomplished, the team progressed to the measure phase, where data was gathered to produce the baseline measurement using a measurement system flowchart. By early April, the team was ready to begin the analyze phase. The team analyzed process failure modes by utilizing the FMEA and the cause and effect diagrams to identify potential root causes, which takes us to our current phase, the improve phase, where we use brainstorming and a prioritization matrix. Throughout the course of this presentation, we will go into further detail of each individual phase and our findings. Our organization and project definition are as follows. Team 4 decided on the System Support Division of the City of Houston Municipal Court Departments, otherwise known as MCD. Within the MCD is the IT division, which provides around-the-clock technology management 24 hours a day, 7 days a week, 365 days a year. Both internal and external stakeholders are supported. The focus of our Six Sigma project is to improve the efficiency of user setups by reducing the amount of callbacks to the IT division. A user setup is defined as a workstation setup, access to applications and software. Callbacks are defined as the subsequent tickets created for the same user and issues submitted within the next 30 days of the original ticket.
One of the initial tools we used in the define phase is the SIPOC diagram. A SIPOC diagram is a high-level tool used early on in the Six Sigma process. Our team found it helpful because it allowed us to brainstorm and identify the various steps and resources utilized by the City of Houston's MCD IT division. Beginning in the middle with the process steps, the first step is the requester initiates the request. Then the help desk obtains the data and analyzes the request. Next, a ticket is created and assigned to a technician. If additional information is required, the requester is contacted and the necessary information is gathered. If no additional information is needed, the setup is performed, and once complete, the appropriate parties are then notified. A survey is sent to the requester and the ticket is closed. The inputs are the request, access form, user profile, technical requirements, heat system, and customer feedback. The suppliers are MCD management, MCD IT staff, and the internal and external users. The outputs for the SIPOC diagram are workstation setup, notifications, application access, and customer survey. Finally, the customers are identified as the internal and external users. The next slide is the measurement system flowchart for our project. During the measure phase, we need to verify the measurement system so as to ensure that we collect good quality data and make good decisions. A measurement system flowchart depicts the process of collecting the data and then verifying the collected data. Since we did not have specific fields to collect the callbacks data, we had to manually go through the data available and determine whether a particular entry was a callback based on the description field. So our flowchart starts with help desk enters the ticket, then the technician updates the ticket. After that, the controller creates the queries for gathering monthly data. The heat system then generates the reports based on these queries. Then 3 analysts analyze the data. Data is manually analyzed. Each analyst calculates the various counts, including the total number of user setup tickets during the time period being analyzed, the total number of callbacks for each month, and the total number of callbacks for each category. The analysts fill the check sheet provided to them for data collection. After all the analysts complete the analysis and fill their respective sheets, then group effectiveness is used to verify the data collected. If group effectiveness is more than 75%, then the data will be verified. Also, the blue boxes on the measurement system flowchart are the improvements we are suggesting to introduce in the new measurement system. These include a standardized script and a standardized ticket format that can be used by the help desk in the future.
Once the data is collected, we need to set our baseline against which we can measure our improved performance. To set the baseline for our project, we decided to use a run chart which depicts the callback percentage for each month. We calculated these percentages by dividing the callback count for each month by the total user setups for that specific time period. The horizontal line on the run chart depicts the average callbacks for all the 3 compiled months, resulting in an average value of 18.1% with a standard deviation of 11.4%. For our project, we have defined our problem statement as the City of Houston's MCD IT division has averaged 18.1% callbacks on setups over the last 3 months, resulting in wasted time for the IT division. And the mission statement as reduce the average percentage of callbacks on setups to less than 10% in the next 6 months, resulting in a decrease of wasted time of 1,506 hours and savings of $34,300 annually for the IT division. Coming to our cause and effect diagram, we brainstormed many ideas and came up with the following potential causes that we felt led to the callbacks. We classified all the potential root causes into 5 main categories that lead up to the increased number of callbacks. These categories are environment, process, people, equipment, and measurement. We involved people who were working in the company for their inputs, which further populated our data.
After we have brainstormed the list of potential causes, we use the FMEA tool to identify and prioritize the potential root causes. This slide depicts a sample FMEA for our process. We conducted the FMEA for each of the 24 steps in our process. Next, we sorted the steps based on the value of risk priority number, that is RPN. Furthermore, we assigned a priority number based on the rank value of RPN. Consequently, the highest RPN value received the highest priority number of 1. The FMEA revealed the top 3 critical steps indicated by priority number 1, 2, and 3. First priority step is obtain data and analyze request. In this step, we identified informal process, lack of training, and different needs per user profile as the potential causes. For this project, our priority 1 revealed an RPN value of 640. For second and third priority step, setup process and complete setup, we identified lack of quality assurance as the potential root cause.
Our failure mode and effects analysis resulted in the identification and prioritization of the critical X's for this project. The top 3 priorities became our focus area. After prioritizing the root causes, we developed practical questions. For instance, does the cause poor process documentation lead to creation of callbacks? Moreover, does the cause lack of quality assurance on part of the service desk or technician lead to callbacks? Asking these practical questions really helped us to carry out an in-depth analysis of the root causes and brainstorm the list of possible solutions. After several brainstorming sessions, the team was able to identify and develop several possible solutions for the prioritized root causes. Areas for improvement were documented via this brainstorming matrix. During the improve phase, the team developed the prioritization matrix. In this matrix, the team incorporated the voice of the customer by including the desired characteristics for each possible solution. Members of our sponsor company were interviewed to receive feedback and provide assistance in completing this tool. The purpose of this matrix was to prioritize and compare the solution's feasibility against the customer's desired characteristics. The result of this analysis revealed that the standardization of setup forms is the highest priority in order to decrease callbacks. The team will focus in improving the top 3 solutions priorities. However, per our stakeholders' directive, the improvements to the heat system and the training solution would not be a feasible strategy due to budget restraints. Therefore, although this priority value is higher than the other solutions, the team will not be able to consider them for implementation. In conclusion, during the last 4 months, this team has been able to identify potential root causes and their corresponding solutions. This slide presents the project's next steps. We will continue an open line communication with our customer in order to keep our customer informed, receive additional input, and gain improvement acceptance. We will formulate our solution strategy and consequently implement our proposed solutions. Once the implementation is complete, we will develop process control plan. Over the next few months, the team envisions to improve the quality of setups within our city for the Houston's Municipal Court System Support Division. We will strive to reduce the average percentage of callbacks, resulting in cost savings
and a decrease of wasted time. Thank you.